Hey there kids, welcome to another math lesson. This is for Eureka Math, grade 5, module 4, lesson 17, homework. And it's really exciting because we're getting into kind of a fun little model to help you understand what a fraction of a fraction is. It's just taking a piece of something that's already a piece of something else. And the objective is at the bottom. We're relating decimal and fraction multiplication. So we're just going to show the connection between like this fraction here, 1/10, which is connected or exactly equal to this decimal here, 1/10. Reading the decimals correctly is going to be a big help for you in writing them. So it's not 0.1, it's 1/10. So that's the big key here in this lesson. So the model is the shading, and yes, you do kind of have to do the shading. I like to show the whole shading, not just the piece of, even though this is where the answer is. If I was going to do the crisscrossing, this would be the opposite direction all the way over. In the book, they have this, what I call double shading. It's like a shade over a shade. But kids have a hard time doing that and making it look good. So we will try our best. I'll show you what we're going to do in a second. Let's take a look at what they would like you to do. We're going to multiply and model. These are the models. Thank you for making them for us so we don't have to do a 10 by 10 square each time. You're going to rewrite each expression as a number sentence with decimal factors. We're going to take the fractions and turn them into decimals. First one's done. Like so. We have 1/10 of 1/10. Remember that of is multiply. That's what it means. And so when you see a fraction of a fraction, that means we're going to multiply them. So it's 1/10 of 1/10, knowing that 1/10 is going this way out of 1. And then we're going to take 1/10 of that. That's this sideways. We're taking 1/10 of 1/10. So when you do 1/10 times 1/10, you get 1/100th because 1 times 1 is 1, and 10 times 10 is 100. Now we're going to show this in decimal form, this in decimal form, and this in decimal form. It's all the same thing. You know how they love to be redundant. We're doing the same thing over and over and over again. Super fun. Okay, so 6/10 times 2/10. So we're taking 6/10 of 2/10. So the first one, remember, is going to be this fraction modeled vertically. Okay, so show or shade to vertically. And again, you should be having this as a check to what you did as opposed to doing it with me right now. You should have already done it. So think on your own. If this is the 2/10 vertical model, then the 6/10 should be where? Now you can have it on the top or the bottom. Here they have it on the bottom. I tend to do things on the top. It does not matter. It just means you have to have 6 of them. So instead of shading to the right, if that's a problem for you, 1, 2, 3, 4, 5, 6, we're going to go all the way over to here. If you want to do the double shading, you can do that, or you can shade it this way. And again, technically, we're taking, if this is 6/10, then all of these would be shaded. Does it drive you crazy that I'm doing all these in different directions? Okay, so what is the area that is the double shading? See what I mean by it's hard to create the double shading? This right here is where the answer is. This is 1 out of 100. That's what that answer is equal to, that tiny little piece there. So your answer is going to be right here. 2, 4, 6, 8, 10, 12. Yes, 6 times 2, 12. 10 times 10 is 100. Let's take it apart like they would like us to. 6 times 2 over 10 times 10. Instead of simplifying here, we're just trying to match the pictures to the model. So here's your 12, here's your 100. Now take these and turn them into decimals. 6/10. Remember back in Module 1, place value positions? This is the tenths place you may have forgotten. You're going to multiply by 2/10. 2 in the tenths place you may have forgotten. your answer is, it's the 12. Now I want you to look at this 6 times 2 for 12. We're connecting this fraction answer to the decimal form. And so you should have 0.12, which is 12 hundredths written properly in decimal form. So that's the connection we're making today, is to connect this fraction model to the picture to the decimal. Okay, hopefully that is pretty clear. All right, now this one goes all the way across because it's 1/10 of 1 6/10. 1 6/10 is how you read that properly. So this is my model for what I'm starting with. Remember the second fraction. So if I have 1 6/10, that means this whole entire thing is shaded. All 100 squares shade the whole thing. That's 1. Now I need 6/10. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Be careful. Go all the way down. This is your 1 6/10. Quite a lot of shading. Some of my students will just do a massive scribble and then they'll erase what they did outside the lines. That's fine. Whatever. Okay, now we're going to take 1/10 of that. Okay? 1/10 of 1 6. So the horizontal way is going to be where the 1/10 is. So in an opposite direction, or just double shaded, a little bit heavier, but across both. And if you, can you stop there? Yes, the book will stop there. I tend to go all the way across because these are not being counted, and yet it is 1/10 of it. So just showing that that is 1/10 all the way across. But the double shading is where the answer is. So turn everything into a fraction, or in our fraction multiplication, remember that you can rename a decimal like this. So we're going to rename the whole thing by this place value position. So I have 1/10 times how many tenths altogether? 16 tenths. You may have forgotten that. Just trust me, you can do that. So when you rewrite it, it's 1 times 16 over 10 times 10. Okay, so put this all on the top and then all this on the bottom. 1 times 16 is 16. 10 times 10 is 100. Now that would make sense. This is 10 here. Plus 6 is 16. Out of 100, this being the one whole. Okay? So now let's change this into decimals. 1/10, 1/10 times, this is already in decimal form. And we know our answer is 16 hundredths, so I have to, if you were going to fill in blank lines, and I have 16 hundredths, this is the hundredths place. So my 16 has to land here or finish here, so you can kind of back out, and that's how you know you're going to end up with your 16 hundredths in the proper place value positions for this answer. Okay? All right. Next one at the bottom. The whole here, I know it's going to focus just momentarily. Yes, it is. Oh, thank you. The whole here is 1 9/10. As if that wasn't enough fun shading, we have to go all the way across both squares, but don't shade that very last column. Now, it's not art class, it's math class, so just scribble it out. If you haven't already, if you already did it, good job. Good job. All the way across. And 9 more. All the way here. I'm going to be real careful with that last column, the 9th column, and then I'm just going to scribble it out. Okay. So make sure it's all shaded for your 1 9/10, or what we're going to call 19 tenths. It ends in the tenths place. That's how you know what your denominator is. 6 tenths of that is what we're going to take. So instead of having 1, we're going to have 6. Let's say we want to copy this. We're going to do it from the bottom. So we go 1, 2, 3, 4, 5, 6. This right here to the bottom, all the way across both is where your answer is going to be. So that's going to be a bigger answer than the last one. Oh, so scribbly. And again, the book does not scribble this out, but I'm showing you just for consistency that these are not part of the answer. The answer is right here in the double shaded region. Okay, so let's use our numbers to create our answer. So if I have 6/10 times 19/10, I'm going to do 6 times 19 over 10 times 10. 6 times 19, if you want to use your standard algorithm, that's great. If you want to do it this way, you can always carry over the tens place right here. So 6 times 9 is 54. Carry the 5 over the tens place. 6 times 1 is 6 plus 5 is 11 over 100. Noticing that this is actually greater than 1. So if I was to take all these squares and fill up this whole region, I could do that and I would have a number that's greater than 1. So what does 114 hundredths look like as a decimal? Well, let's create it. I have 6/10 times, what's 19/10? 1.9. Remember that when we start with our decimal value that is greater than 10, that's going to be bumped over into the next place value position. Okay, it's been a while since we've talked about decimals, so this is a really good review. And then we know the answer is 114, but where does the answer fall if I have my place value positions, ones, tenths, hundredths? This is where my decimal is going to finish, and I have a 3-digit number, so it's going to be 114. 1.14 or 1 and 14 hundredths. Okay, hopefully that is what you got. Be careful with your place value positions. All right, now on this section here, we are shown what they would like you to do. It's multiple steps. Don't shortcut, because it's really important that you can do all these things. Sometimes kids are like, oh, I don't have to do as much over here. No, you actually have to show the answer. So multiply the first few are started for you. 4 times 6/10. 4 ones times 6/10, fraction form. 4 times 6 over 10. So that is taking your whole number and putting it over 1, which you would then multiply by the 10. So there's nothing left down here of the 1. It's just times 10. Do the multiplication, then show your answer in decimal form. Don't smash it in on the answer line down below, so give yourself some space. You'll have even less space down here. It's so fun. So when you have your final answer, yeah, you can put it up here, but it's not really a big deal. Just circle it. Okay, 4/10 times 6/10. Take your 4 times 6, 10 times 10. 4 times 6 is what? We already solved it, so not a stretch here. 10 times 10 is what? That's new. So instead of 24 tenths ending in the tenths place here, we have 24 hundredths. What does that look like? That looks like this, because 24, the 4 needs to be in the second place value position over. How about this one? Taking 4 hundredths, watch out, they moved it over, so they're going to change the value of these numbers. Watch your denominator, 4 100ths times 6/10. So what do? You still have 4, you still have 6. Move your denominators down here and then calculate them, 4 times 6 being 24. But 100 times 10 being what? That's right, you should have 3 zeros. 1 times 1 is 1, and 1, 2, 3 zeros for 1,000. So what is 24 thousandths? What does that look like? That is going to be tenths, hundredths, thousandths, if you remember your place value positions. It's only a 2-digit number, so where do you put it? You finish in the thousandths place value position, work backwards if you need to, but it's going to be 24 finishing here, 0.024. Okay, hopefully you got the hang of it, because now we're just going to do the same thing over and over with all these similar numbers. Don't have any new facts that we're memorizing, but the different place value positions. This is a really great review. So I have 7 ones times 3 tenths. Copying the format. Copy the format. 7 times 3 over 10. Copy the format. 21 tenths. Not enough room, like I said. Go next to it and finish in the tenths place, which means you might have to back out to the other side of the ones and have 21 tenths or 2.1. Hopefully you got that. That's a real test of your knowledge there. 7 tenths this time times 3 tenths. 7 times 3 over 10 times 10. Let's save space here. 7 times 3 is 21. 10 times 10 is 100. So I have 21 hundredths. What does that look like in standard form decimal? And so in your 2-digit answer, we have room for 2 digits over here. Tenths, hundredths. 21, so 0.21. Next one. It's not 7 tenths, it's 7 hundredths. Times what? 3 in the tenths place. That's going to be 7 times 3 over 100 times 10. Solve that, and again, not a stretch. They're not trying to surprise you. It's just about where do you put these digits. 100 times 10 is 1,000. What does 21 thousandths look like? It looks really similar to this one. If this is a 2-digit over a thousandths place value, it's going to be 0.021. Next row. 1.3, 1 and 3 tenths. 13 tenths times 5. 5 being the whole number, just like it was up there. 13 times 5 over 10. 13 times 5. Use the standard algorithm over here, or just solve it by carrying over your number into the tens place. 5 times 3 is 15. Carry that 10. And then 5 times 1 is 5 plus 1 is 6. 65 tenths. This is a real test. How do you write this in decimal form? 6.5. Tenths place is where your number has to end. Next one, 1.3 is 1 and 3 tenths. If I have all these tenths, I can call it 13 tenths. Times how many? 5 tenths. Rewrite it. 13 times 5 over 10 times 10. I want to solve that so badly and just say it's 100. 13 times 5, you already solved it, so don't belabor this issue. Just move on. We know it's 65. Now solve this. If I have 65 hundredths, think about place value. It's a 2-digit number. I have 2 digits, tenths and hundredths. Put your 65 and move on. The last one is the 13 hundredths. So they've shifted it. It's not this anymore. They shifted it to the right. Now it's in the hundredths place. Times 5 tenths. Same thing again. 13 times 5 over 100 times 10. Now solve. We know it's 65. We know this is 1,000. No surprises here. The answer is, where do I place my 2-digit number when I have to get to the third place value position out? 0.65. Got to add that 0. Okay? So excellent repeated practice here on this page. This is great practice for you. Okay, word problem is fun. Jennifer makes 1 and 7 tenths or 17 tenths liters of lemonade. If she pours 3 tenths of the lemonade in the glass, How many liters of lemonade are in the glass? So let's start it out with, we've got our 17/10, and we're going to take 3/10 of that. When you have this, remember, where does it go? Second. Taking a fraction of it, where does that go? First, take a portion, this of this. This is what you have. This is your, what you could say is the whole. Okay, and we're going to take a portion of the whole. So when you have this, you can, we're learning how to change it into decimals. You can leave it as the fraction form. It doesn't say in the directions that we have to do it in any particular way. So if you just do what we were doing, multiply across, 7 times 3 is 21, carry the 2, 3 times 1 is 3, plus 2 is 5, 10 times 10 is 100, so 50/100ths. If you show it in decimal form, and it's going to be liters in the glass. And that is hopefully what you got for number 3. Okay, Cassius walked 6/10 of, again, of what? A 3.6 mile trail, a 36/10 mile trail. How many miles did Cassius have left to hike? So, knowing that 6/10 is the portion that was done, out of the 10/10 that Cassius has to do, what's left? 4/10. That is left to hike. Key reading. If you mess that up and you did 6/10, because it's right there in the problem, I know lots of kids are going to mess that up, but fix it. Pause the video, fix your math, and then check back. So we really need to know what 4/10 of the 36/10 is. So you can start with this. You can start solving. 6 times 4 is 24, carry the 2. 4 times 3 is 12, plus 2 is 14. And 10 times 10 is 100. So I have 144 hundredths. What does that look like? Here's my hundredths, and it's a 3-digit answer. So out of the 3 6/10 miles, there's only 1 4400ths miles left to hike. And hopefully you got that. Now, Cameron was 1 3/10 miles ahead of Cassius. How many miles did Cameron hike already? So Cameron is 1 3/10 miles ahead. Now, if we have the 3 6/10 miles, that is the total, and we have our 1 3/10 miles that he's ahead, and he still has this much left to hike, we need to find the difference between what's left to hike and how much farther ahead Cameron is. So finding the difference, he's almost done. And then here, remember, decimal down. And so how many miles does Cameron hike already? So that's how much he has left, but that's not what the question is asking. So go back to the 3.6. He's really close to the end. Oops, make it not hang out there in the middle, because you have to line everything up by place value. Place value matters. This is the total distance. He's so close to the end, but it's like, how far did he go already? If I was going to do a tape diagram, he's already covered most of that territory. So find the difference by subtracting, regroup here. Take 1, give 10. Subtract, decimal down, and we borrowed from here, and then we did not have to borrow from here. So it's 3.46 miles done already. And hooray! So that is it for today. Hooray! Click subscribe and come back again. I hope this was helpful. We'll see you on the next one. Bye for now.